Most AI agent demos start with a prompt and a tool call. The model searches the web. It reads a file. It runs a command. It writes a result somewhere. That is useful, but it hides a bigger problem. A real worker does not just answer one question and vanish. A real worker has a desk. It has notes. It has half-finished files. It has downloaded inputs, generated outputs, logs, drafts, tests, and a place where work accumulates over time. Software agents need the same thing. Not just memory in the conversational sense, not just a longer context window, not just a function call named run, command. They need a computer. That is the interesting idea behind Cloudflare Computer. It is a preview project from Cloudflare, and the README is very explicit that it is not production-ready yet. The APIs are unstable. It is meant for experiments and feedback. But as an infrastructure signal, it is important. Cloudflare is not just asking, what tool should an agent call? It is asking, where does the agent's work live? The answer is a durable workspace. Cloudflare Computer is built around a virtual file system that lives inside a Cloudflare durable object. The authoritative state is stored in SQLite. On top of that, the package exposes a file system API. Read files, write files, make directories, list directories, grep, edit, delete the boring operations that every working directory needs. Then it adds execution. There is one main execution surface, workspace.runtime.exec. Depending on the backend, that can run a shell command or an isolated JavaScript module. The important part is that the code runs against the same durable files. So the center of the system is not the model. It is not even the runtime. The center is the workspace. That sounds small, but it changes the shape of agent infrastructure. Today, a lot of agent systems feel like disconnected tool bubbles. One tool fetches something, another tool runs code somewhere else, a third tool writes an artifact to a different store. The model tries to hold the plan together in context. If the context is lost or the run is interrupted, the agent has to reconstruct what happened. A durable workspace gives the agent a physical metaphor again. There is a file tree. The agent can write a note, run a script, inspect the output, modify the script, and publish the final artifact. The next call sees the same files. Cloudflare Computer has 3 current runtime shapes around that workspace. The first is the container backend. This is the most computer-like version. A Cloudflare container runs a daemon called computer D. The workspace is projected into the container as a fuse mount, so code inside the container sees a real file system. That gives you a full Linux userland, real binaries, and real network access if the policy allows it. The second is the worker shell backend. That runs just bash inside a dynamic worker. It is lighter than a container. There is no Docker image and no full Linux machine. But it can still run useful shell-style commands against the same workspace. And file system operations round-trip back to the durable object. There is one authoritative store, not a second file system that has to be reconciled later. The third is the worker JavaScript backend. That executes an isolated ECMAScript module with structured input and output, durable relative imports, and access to workspace-backed file operations. This is not trying to pretend every job needs a shell. Sometimes the right execution surface is a clean JavaScript runtime. That backend split is the architecture lesson. For an agent, run code is not one thing. Sometimes you want a cheap text processing shell. Sometimes you want a full container with native binaries. Sometimes you want isolated JavaScript with strict structure. The workspace stays stable while the runtime changes. That is the difference between a tool call and a computer. A tool call is usually a single capability. A computer is a place where many capabilities operate on shared state. This also fits directly into the MCP and code tool world. The repository includes an MCP example where the client sees one public tool named code. Behind that tool is a durable workspace, a worker shell, and a full Linux container. The model does not need to individually call every primitive. It can write a small function that reads files, writes files, executes commands, and returns the result. That is closer to how a developer actually works. You do not solve a problem by calling one magical API. You create files, inspect them, run tests, read errors, change the files, and try again. For agents, that loop needs state. It also needs policy. This is where the story gets more serious. Persistent files plus executable code are powerful, but they are also risky. If an agent can write to a workspace and execute what it wrote, the infrastructure has to answer uncomfortable questions. What can it access? Can it reach the network? Which runtime is allowed for this task? Are artifacts publishable? Are logs observable? Can one user's workspace leak into another user's workspace? Cloudflare's design makes those questions explicit. Worker shell can run without ambient public internet. Container execution can be more capable, but heavier and more sensitive. The examples talk about egress policies, artifacts, MCP authentication, and runtime selection. That is exactly where agent platforms are heading. The hard part is not giving a model a bash tool. The hard part is giving it a bounded computer that is useful enough to do real work and constrained enough to trust. There are also practical limits. The documentation says the workspace is roughly a 10 GB scale primitive because it shares storage with the durable object. The container-side file system is held in memory, so this is aimed at agent-scale working directories, not giant monorepos or warehouse-scale storage. The performance docs are also refreshingly mixed. The Fuse-mounted workspace can beat a normal ext4 disk on some metadata-heavy operations, things like stat, remove, directory traversal, git initialization, and shallow clone. But it is much slower on large sequential file, I/O, and a full npm install is slower than the container's native disk. That matters because the correct conclusion is not replace your file system with this. The correct conclusion is agents need a durable, portable work surface, and that surface has different trade-offs than a raw disk. For a coding agent, editing a few files, writing notes, storing artifacts, and running small commands, the workspace abstraction makes sense. For huge bulk I/O, it may not. And again, this project is preview only. Treat the API as a signal, not a settled standard. But the category feels real. Over the last year, the agent stack has been climbing upward. First, models learned to call tools. Then tools became protocols. MCP made capabilities portable. Skills started packaging workflows. Memory systems tried to preserve useful state. Harnesses started orchestrating multiple agents. Browser and GUI agents tried to operate software the way humans do. Cloudflare Computer points to the next layer, the agent's own working machine. Not a screen that the agent clicks, not just a browser, not just a vector database called memory, a scoped file system, a runtime router, a place to accumulate work, a policy boundary, a publication path for artifacts. If agents become a major cloud workload, every infrastructure provider will need some version of this. They will compete on how fast the workspace is, how safe the sandbox is, how cleanly it connects to tools, how well it observes execution, and how easily it publishes the things agents make. That is why this matters even if you never deploy Cloudflare Computer itself. The durable workspace is becoming a primitive. And once you see it, a lot of agent architecture looks incomplete without it. A chatbot can live in a context window. A worker needs a computer.